In this tutorial, we are going to be focusing on the notation system for writing the electronic configuration. First of all, what is electronic configuration? An electronic configuration is always a method of describing the arrangement of electrons in an atoms or ions which indicate the specific orbitals and the numbers of electrons they contain. And this provides a shorthand for representing of how electrons are distributed among the various energy levels and the sub-levels within an atoms. First of all, if you notice, this is what we call the atoms, and this is the structure of another structure of an atoms. And when we say an atoms is simply the basic building block of all matters in chemistry. Atom can combine with other atoms to form molecules, but cannot be divided into smaller parts by ordinary chemical processes. And here in these atoms, inside the atoms, what you can see, you'll find several subatomic particles. And these subatomic particles can be protons, neutrons, or electrons. Notice that outside of the shell, we have what we call the electrons, and they are negatively charged. Inside of the cell, we have two things, which are the protons and the neutrons. When we talk about the energy level, the energy levels, this is outside. Here, we can call them the region around an atomic nucleus, where electrons are likely to be found. These shells are numbered starting from 1, 2, 3, etc., etc., and this is how it continues, with each shell able to hold a specific maximum numbers of electrons. Electrons fill the shells in increasing order, meaning starting from 2 to bigger numbers, starting from the innermost to the outermost. The first shell can hold maximum 2 numbers of electrons, the second shell is 8, and the third shell is 18, and so on. And this pattern follows the principle of quantum mechanics. So the next thing we need to look at is while writing the electronic configuration, you need to consider the shell. So first you need to understand, while considering the shell, the maximum numbers of electrons can be accommodated in the shell is based on the principal quantum number, which is represented by the formula 2n to the power of 2, where n is the number. In this case, remember, we have this. Let's say we have 1s to the power of 2. In this case, the s simply stands for numbers of electrons. Numbers of electrons, and this is simply the types of orbitals. And this is what we call the energy level. So this is the formula we are given. In this case, let's say we have the nucleus K, L, that's numbers of orbital, L, M, and we have N here. Notice that the K, that's the K shell, is the first one, which is going to be 1. Inserting this into this number, we're simply going to say 2 multiplied by 1 to the power of 2. 1 to the power of 2 is simply going to be 1 multiplied by 2, which is simply going to be 2. In this case, the maximum numbers of electrons present in the shell is simply going to be 2. Therefore, our K shell is simply going to be 2. What about the next one? The next one is L. Remember, if this is 1, this is 2, this is 3, this is simply going to be 4. Our L is equal to 2, which is the same thing as saying L shell. The N is simply going to be 2. Inserting into this formula 2n to the power of 2, which is simply going to be 2 into bracket of 2 to the power of 2. 2 to the power of 2 is simply going to be 2 multiplied by 4. And 2 multiplied by 4 is simply going to be 8. In this case, we can conclude that said the L, the maximum numbers of electrons present in the L shell, is simply going to be 8. Let's try the next one. What about M? In this case, M, which is the third one, we can say M shell is simply going to be 3. Inserting this into this formula, this will give rise to 2 into bracket of 3 to the power of 2, which is simply going to be 2 into 2 to the power of 3, which is simply going to be 9. 9 multiplied by 2 is simply going to be 18. And this is how it continues. Let's get rid out of this and create some space to see how we can calculate some problems. So, next thing we're going to look is the notation system for writing the electronic configuration, because we have already looked at the definition and few example explanation with some formulas. Notice that the electron shell is represented by a number, that is the principal quantum number, followed by a letter indicating the types of orbitals, which I showed here. We said this one represents the energy level, type of orbital, and we have the numbers of electron. The type of orbital, remember, we have the S, P, D, F. If you are interested, first of all, I'm going to provide you with some mnemonics or some formula or trick steps which can help you to write the numbers of the notation for writing the electronic configuration easily. Let's say here we have S, P, D, F. What we need to do is to write this backward in two places. I don't know if the English is right, but what I'm trying to explain here is this. This is 1, this is 2, this is 3, and this is 4. And remember, the formula we use is 2n to the power of 2. And we said the numbers of electrons, we have K, L, M, N. When you insert, if this is 1, this is 2, this is 3, and this is 4. If you insert 1 into here, multiply by this, therefore our K is simply going to be 2. Our L here, we said is simply going to be 8. And K, L, M, and M, we say is simply going to be 18. So what I'm trying to explain here is this. Here, next thing you need to do is to put this in two places. Here is going to be S, S. So next thing, instead of us to start from the right hand side, or anyway, we're simply going to start with the left, moving this side to the S again. In this case, it's going to be P. Remember, write everything in two places. It's going to be PS into TS into two places is going to be PS. Next thing is third one. We are going to repeat that in two places again, but we are going to first of all write it from D, P, and S into two places, meaning that this is simply going to be D, P, and S, D, P, and S. What about the last one? I want to repeat the same procedure, which is going to be F, D, P, S, F, D, P, S. In this case, notice that our K, which is S, K is 2, S is 1, here is going to be, meaning that all S carries two numbers of electrons. In this case, we're going to go ahead and find where we have our S, we're going to donate two numbers of electrons. Since here we have the superscript and we have the subscript. And we said the superscript is numbers of electrons, while the subscript here is the energy level. And this energy level is number 1. We're going to donate S by 2 throughout this process. So what about the numbers, the energy level? Energy level is simply going to be 1. If this is 1, this is going to be 2. You find the next X, which is going to be 3. This is going to be 4. And this is going to be 5, 6, 7, and 8. Next thing we have on the list is P. In this case, notice that P is the second one. Instead of 1, we're going to put 2. And how many numbers of electrons is P carrying? P is carrying 6 numbers of electrons, because we already have 2 from the inside plus, instead of 8, we have 2 from the inside. We're going to be left with remaining 6. Here, P is going to be 6 numbers of electrons throughout. Anywhere you see P, put it. Remember, in the case of the subscript, I'm following it serially. In the case of the superscript, we are only putting the numbers of electrons, which is the same thing for every orbital. So, this is 2. The next P we see on the list is going to be 3. Immediately, is there any P on this line? No. Next is the next line, and we're going to if this is 3, this is going to be 5. Sorry, 4. And this is going to be 5. This is going to be 6. This is going to be 7. What about the next one? If this is 1, this is 2, the D is going to be 3. This is going to be 4. And this is going to be 5. This is going to be 6. Numbers of electrons on D is simply going to be 10. Here is going to be, anywhere you see D, just feel free to put 10, 10, 10, 10. I'm sorry, this is F. It's going to be 10. So this is going to be 4. It's going to be 4. Numbers of electrons on F is simply going to be 14. 14 plus 8. No? Yeah, 14 plus 4 is simply going to be, that is 18, which is this. Here is going to be 4. Here is going to be 4. And this is for this problem. But you can choose to write it differently by saying, instead of us to follow this pattern, you can choose the easiest one by saying, since S is the first one, S, S, S into 7 places, which is 1, 2, 3, S, 4, S, 5, S, 6, and S, 7. And we said the numbers of electrons on S orbitals is simply going to be 2, 2, 2, 2, 2, 2. Next thing we have on the list is P. So in this case, the P, I'm going to write, instead of the first one, is going down P, 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 P. And in this case, the P, this is going to be second. 2, 3, 4, 5, 6. Numbers of electrons on P is 6, 6, 6, 6, 6. Next thing we are going to write is the third one. And third one is going to start on number 3, which is D, 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 D. Our subscript, which is the energy level, is the third one. 3 is going to start with 3, 4, 5, and 6. Numbers of electrons in this is simply going to be 10, 10, 10, and 10. But then the final one, which is F. In this case, F is going to start not immediately after this. It's going to start with this, this, and this. Numbers of electrons is 14. It's carrying 14, 14. And this, instead of 3, is simply going to be start with 4, 5, and 6. So this is it for this problem. I hope you find it helpful. Feel free to like, share, and subscribe. And also, I also have some problems which are solved relating to this topic. Thank you for watching, and see you next time.